Okay. I think that we can start.
Yeah.
Yes. So I want to say hi to everyone and thank you for joining us today. And I would like to start by saying that I'm very happy that we are holding this type of event. And for the first time, we have this kind of like co-organization between three countries, Serbia, Croatia, and Slovenia. That is that we are gathering students from three different Google Developer Student Club and from three different universities. Although we are from those three countries and we understand each other when we talk, we agree that today's lecture will be held in English because, of course, of our lecturer, Pablo, and all those who are interested and not from our universities. Tako da svi pomalo da vežbamo engleski. So today's lecture is special, and it is our honor that the theoretical part of the lecture will be held by Google developer expert Pablo, after which GDSC lead Luka from Croatia will hold a technical workshop. Something short as an announcement about today's topic is that the Google Apps script is a powerful platform that automates tasks and creates custom applications within a Google workspace. Now, I would like to leave the floor to my colleague Nevena, GDSC lead from Slovenia, to tell us something more about today's lecturer.
Hello, everybody, from my side. Good evening. It's an absolute pleasure to be here with all of you today. As Maša already said, I'm the DSC lead at the University of Primorska in Slovenia. And now I would like to tell more about our first speaker, Pablo Felip. Pablo is the head of studies, ICT, and quality management in a private educational institution in Spain, and also Google developer expert. Most of his professional career has been closely related to education, both an internal management and quality assurance positions, as well as a teacher or trainer at different stages and areas, from non-formal capacitation programs to formal vocational training and higher educational degrees. As a consequence, his goal and passion is the continual improvement of organizational and teaching and learning processes through innovative methodologies and ICT tools. He has been using, deploying, and administrating G Suite since 2010, and more recently, leveraging Google Sheets, App Scripts, Data Studio, and other Google Workspace services to build automations that improve the workflows of corporate processes, provide performance insights, and assist in decision-making situations. Pablo is a member of GEG Spain's coordination team since 2018. For those who don't know, GDG is Google Education Group. Today, we are fortunate to have Pablo sharing his knowledge on Google Apps Scripts. He will give you a talk, as Maša already said, about Google Apps Scripts, and you will get all the necessary information on the topic. Following the talk, we will have our second speaker, Luka, who is our colleague and GDSC lead at the University of Zagreb. He is also a computer science student at the Faculty of Electrical Engineering and Computing. He will hold a workshop on the same topic to show you some real-life examples of using Google Apps Scripts, like, for example, connecting your Google Calendar with Google Sheets and similar. Without further ado, we are thrilled to have them here today and can't wait to hear their valuable insights. Pablo, the stage is yours.
Thank you very much, Maša, Nevena, Luka, for the invitation, and thank you to everyone who is attending this talk. Well, I have prepared a slide talking a little bit about me, but well, I think that it's useless just now. So Nevena has explained perfectly who I am, but anyway, I am not here to talk about me, but to talk about AppScript. So let's move on. I'm going to I have divided this presentation into 4 parts. First, we will talk about what is AppScript. Then I think this is the most important part. What can you build? What can you build with AppScript? How you can share and publish your apps, your creations, and well, some next steps, some advice, and some additional resources that maybe you will find interesting if you try to delve deeper into apps scripting. That's my goal today. You can stop me whenever you want. As you may have noticed, English is not my native language. I am from Spain, Castellón. I here this little point here, not even in the map. So this is a small town between Barcelona and Valencia. Maybe that those names ring your bell. And well, I talk quite a lot, but I also like to answer questions. So whenever you feel like, please, I don't know if you can raise hands here or just comment, but I'm sure that the co-organizers will be keen to translate, to move those questions into a stage so that we can proceed swiftly. So what is AppScript? I always like to define AppScript as some sort of glue that sticks together all Google products and services. You can use AppScript to develop automations that move data around and automate things. That's the idea. And you can do this at zero cost. And the nice thing about AppScripting is that if you pay money, you are not getting a better AppScript version. So you can be confident that whatever you can do at no cost is what really can be done. So some features. It's AppScript is used through a cloud-native rapid application development platform. So it's a coding environment, maybe low code environment, because there are some complexities that are not present here. But in the end, what this means is that you are going to be able to develop fast, to develop automations, to develop apps in a very sort of easy way. It is available for consumer as well as paid Google account. So if you have a Gmail account, you can use AppScript. If you have a workspace account, maybe at your universities you are using this kind of accounts, well, it's available for both of them. In the end, it runs modern JavaScript code, but server-side. So this JavaScript code is running up in the cloud in Google servers, not in the browser. Okay, so that's a key feature in my view. It's using the V8 runtime, just the same as Chrome, so you can expect almost all to be on par with the feature set of the JavaScript you can run inside the browser. The second key feature in my view is that you can access users' data, be it Gmail, calendar, docs, slides, drive, very, very easily. You don't need, although you can, if you want, use any API or complex workflow with authorization to get access to all those data, all that data. Besides that, you can also connect with external services not provided by Google. For instance, you can pull courses from a Moodle server. That would not be a problem for AppScript. So you can go beyond, you can reach beyond the workspace realm and connect services that are coming from third parties. For that, AppScript has some API features, RESTful API features. It's a service we'll see later on the presentation, that it's called the URL fetch service. With that, you can ping third-party APIs quite easily. But on the not so bright side, it's not the fastest of platforms. Just don't intend to program a game, a video game, an action game here, for instance. There are no promises, no async await. Well, in fact, the syntax accepts using promises and async await, but there is no asynchronicity, so they are not of no real use in a real world scenario. And we don't have ES6 modules as well either. So, well, we have something similar that they are called libraries, but in the end, what this precludes us to do is just scale the apps, our apps script programs, creations, or apps beyond certain extent. Maybe they don't scale well when you try to develop big projects. So, right? Until this point, I would like to ask the public, how many of you can raise hands or whatever, or say hello, how many of you have actually used AppScript? Let's see the chat. No answer? No one? That means no one? Okay, Milan have used it. No one else? Not even heard about it? Okay, no problem. We'll carry on. Maybe when we finish this presentation, you will be more eager to start doing things with AppScript. That's my, as I said before, that's my goal today. Okay, so how can I start doing things with AppScript? It's all in the cloud. Just type script.google.com or script.new in your browser with a Google account. You have to be logged in, and you can start creating wonderful things. This is the look and feel of the GAS dashboard. This is the place where you will manage your projects. You can check also other projects that have been shared with you. You have a trash. You can check your execution logs and set up triggers. We'll talk about triggers later on. Okay, so it's all in the browser. No need to install anything on premise on your computer, even though if you want, if you feel inclined to do so, to tackle greater projects, you can use a tool called Clasp. This is the first and last time I will talk about it in this presentation, to create a local environment, a local development environment that, well, comes with its advantages. But to start with, to develop a small to medium scale projects, the online, the cloud IDE is more than enough in my view. And this is actually the IDE. The former slide was the dashboard. This slide is showing you the IDE, the Integrated Development Environment. You have 5 sections on the left. You have information about the script you are editing now. This leads to the code editor. From this section, you access the triggers. Here, executions of this script, not all the scripts, as we had before in the dashboard. And we also have an avoidable settings button to pull some levers that have to be pulled to adjust the way our script should work. And why are we doing this? Well, I have mentioned it before, and also in the introduction. We have lots of wonderful services inside Google Workspace. Now I'm talking about Google Workspace, not just limited to business or education accounts, not inside a Google Workspace domain. I'm talking about the whole Google ecosystem that can be used, can be leveraged also using Gmail accounts. So whenever I'm talking about Workspace from now on, I'm talking about the whole ecosystem. So you can use all those tools manually using the user interface. That's the way they are intended primarily to be used. But what we intend by using AppScript is automating things. For instance, I could create the schedules of all the classes in my school. I am a teacher as well, so I am the head of studies in my school, and I am in charge of creating the schedules, the yearly schedules. I can do it in a spreadsheet and then push them automatically using AppScript, for instance, to Google Calendar to create schedules for classrooms, for teachers, or groups, or whatever. If I had to do it manually, well, I think that you easily you would easily agree that, well, it's a time-consuming process, also prone to mistakes. If I can develop a script that can do it swiftly and with no errors, that's a great advantage for that one, for the people who have to take care of this. In my school, it's me. So, and of course, as you may have guessed, that's a script I already use in my school, and that saves me a ton of time every year. So another key concept, key feature that we have to introduce right now is the kind of services we can use. There are, in a nutshell, three ways I can interact with these Google apps, these Google tools. I can use what are called in the reference documentation built-in services, also standard services. We also have advanced services, and in the end, we have APIs, REST APIs. And these three elements can be used together, either reactively. I mean, I can develop an apps script that whenever I hit the run button, performs something, but I can also set some triggers that run that script at certain time intervals or when certain events are triggered. For instance, when a spreadsheet is edited or when a new form response is received in Google Forms or in the spreadsheet that is connected with that Google form. Let's talk a little bit more about this distinction between built-in services, advanced services, and REST APIs. Okay, so when we are learning how to manage apps script, we'll be using probably only built-in services. But what are built-in services? In the end, technically, they are global JavaScript objects that let us interact with some calendar, with Gmail, with Google Sheets, with Google Drive, or the rest of services in Google Workspace. The nice thing is that they are very easy to use. Why? Because we don't need to perform that authorization against an external API that is typical in some other platforms. I just type using certain syntax, using certain classes of objects with properties and methods, and just create events. It feels like magic. We also have another breed of services that are more advanced. In the end, these more advanced services let us do things that the built-in services simply are not capable of performing. And they are really thin wrappers for what have to be the more complex way of using those Google services. I'm talking about Calendar, Gmail, Drive, or whatever, Google Keep. All those Google services can be used also by means of their public APIs. Google, in the end, has this as the way, for instance, to use to create Google Calendar events from a different platform that is not AppScript. So what you have behind or below all these wrappers that simplify the way that we code is APIs. When we get to this point, we need to perform an authorization workflow that may be quite complex, but when doing so, we gain some superpowers. We'll talk about them later on. So if you are absolute beginners in the AppScript world, just keep your attention here, built-in services and advanced services. Which are those services? I think that there are over 20, 30, last time I counted them. These are the built-in services. For instance, I have highlighted in green the maybe most frequently used: Calendar, Document, Drive, Gmail, Spreadsheet, Slides, maybe also Forms, but we have more of them: Groups, Sites, Maps, Translate, Data Studio. Well, now it is called Luka Studio, you may know. And we have some support or some auxiliary services that also are useful in certain situations. We also have advanced services, and as you can see, some of them are doubled. Why is it so? because, well, the real reason why they are double, I don't know. That's up to the Google development team who devised all this ecosystem. But the fact is that with the advanced services, you can do things that are not allowed to do with the built-in services. They are harder to use, but they grant you greater superpowers. The caveat to this is that these advanced services need to be enabled on a one-by-one basis in the apps script IDE. Okay, for instance, this is you can see here an example. This is the dialog used to enable this. We'll see probably a real demo of this in just some minutes. Okay. So let me go back for a minute. Whenever we try to pull something with AppScript, we'll start here using the built-in services. If we cannot do it because it's out of reach of the capabilities of these services, we'll move to advanced, and then if it is not possible to perform either with advanced services, we'll have to move to APIs. That's right. So that arrow marks our line of movement. The line of movement we should try to stick to. Well, but even using the APIs, there are things that cannot be attainable right now. For instance, things we cannot do with either the standard service, well, there is no classroom standard service, there is only an advanced service, or the advanced, or even the API. For instance, do you know Google Classroom, the platform? Maybe you use it at university. So with there is no way you can change the position of the coursework items, tasks, questions of researchers. Simply, it can be done. How can you get to know that? You have to study the documentation. There is no other way. For instance, talking about Classroom, that's a platform I use quite a lot at my school. We cannot access the messages users and teachers send each other. We cannot send messages. We cannot count the number of messages that a teacher has sent inside a classroom, course, etc. We cannot manage rubrics right now. Moving into forms, into Google Forms, you cannot create a file upload question. Well, in fact, using the API, you can try, because there is some nice method to do so. But you get this very weird error saying that this feature has not been implemented yet. So that's extremely nice. Another very demanded, requested feature by developers in Google Slides, update linked Google Sheets tables. Not possible. Whichever, advanced, standard, or API, you can simply not do it right now. And moving to Google Chat, right now, you cannot manage users inside a chat space, though this feature, I know that is in developer preview, so I can talk about it without breaking any NDA, and I know that it is coming soon, because you may know that Google Chat is being pushed quite harder by Google right now, trying to position it as a real alternative to Slack and Microsoft Teams. So think about it. Maybe you are trying to do something that can be done with AppScript. So there are limitations, and the limitations come signaled by what the API can do. If it can be done with the API, it can be done. It cannot be done either with the advanced or the lesser standard service. Okay? Are you following me? Yes, more or less? Great. First, working piece of code. This is one of the first scripts I tell my students to in the workshops I teach about AppScript, the practical workshops. This is a very simple script that gets all the classroom courses the person who is running the script has access to. When you see this little moving shaking hand here, that means that you can click and get to the actual code and the demo, just for you, some food for thought for you after the presentation. So let's have a look at it. You can see this script well, I am actually opening a spreadsheet, because many scripts live inside documents in Google Drive, native documents. I'm talking specifically about spreadsheets, Google Docs, documents, text documents, forms, and slides. These are the 4 types of native Google Drive documents that can host scripts inside. And where is the script? Well, the script is herein, just a click away. These lines, we have 42 lines with a lot of comments, are more than enough to create a custom menu here for our script and a command inside that, when triggered, when clicked, obtains all the classes, some metadata from the classes I have access from this account. Okay, course name, the ID of the class, the teacher group email, and the student group email. I could retrieve many other bits of information from this class as easily as that. Just, oh, sorry. It is just 42 lines, no more. Let's have a look at them. If you're familiar with JavaScript, you may find at home here. This is JavaScript, modern JavaScript. But I told you before that what Google has done, and it has been a brilliant idea, is to enrich the JavaScript platform with some global objects or global classes. There is a hierarchy of classes with objects, properties, and methods. For instance, if I want to interact with the Google Classroom service, so to speak, you may have noticed as well that I am mixing the word service. Sometimes I'm talking about AppScript services. They can be standard, built-in, advanced, but I am also talking about Google Workspace services. Those are different. So I have Google Calendar, that's a workspace service, and I have the standard calendar service, the built-in calendar service, and the advanced calendar service. But these two services are AppScript services that interact with the workspace service. Yeah, so I understand that it might be a little bit confusing. Well, getting to the point, I have here a classroom object. Why I have here in this JavaScript AppScript code this classroom object? Why can I invoke this? Because in this code I have gone to settings, project settings. Sorry. Here in the editor, I have added the advanced service with this button. This button pops up. Well, this is in black, but it's the same that you saw just some slides ago. The dialog where you can browse all the advanced services and select which ones I want to add to my script, to my running script. So I have added the classroom service. So in my code now, I can enjoy this very nice classroom class. This is an object. This is an instance of a class. This class has a lot of properties. One of those properties is courses. And then I have a method. That's an action. That's a verb. That's something, a command I am issuing. List. So I am loading into the response const the list of courses that the advanced service, the Google Classroom as advanced service, is returning to me. Right? Much in the same way, this part of the code is just iterating, getting all the information I need. And this second part is processing that information and extracting the course name, the ID, the group email, and the course group email you have seen here in the table, dumped into the spreadsheet. Okay? And this second part, I have to write all those information, all that information into the spreadsheet. I am doing it with another global object, a spreadsheet app. And you're right, this spreadsheet app object has some properties and methods to interact with the spreadsheet this script is running on. Do things start to fit? Yeah, you can say no if it is it is not like that. So in a nutshell, GAS services, I'm talking now about AppScript services, provide a specific JavaScript objects, properties, and methods for our JavaScript code to interact with, that in the end do things with Google Workspace services apps, such as Google Sheets in this simple demo, or Google Classroom. Okay? Let's move on into a more complex example. Well, but before, where can I learn? Where can you learn about all this? Well, evidently in the reference documentation. That's a very, very nice. We were talking before the start of this presentation with Luka. Luka is now an experienced AppScript coder, and he was commenting that, well, the documentation is great. And if you have some background in programming using some other languages, you will find really at home delving into it. So just click here, you get into the reference overview, and you can explore the documentation looking for all those global objects and which objects, properties, methods they have inside. For instance, if I go to Classroom here, I can look into the object, or I can go into Sheets, it's a simpler one, and get into a Spreadsheet app and see all the properties inside this global object, as well as methods and the detailed documentation. For instance, I can change, I can get the active spreadsheet using the getActive method. Just click, and I get here even a very, very evident, a very clear code snippet explaining you how you have to use it. Okay? Well, second example, I have been talking about advanced services, built-in services, and maybe the difference is not clear and up to now. Why I should use one of them before the other? And this demo, this little animation, well, I recorded it. You can check this longer post about it, trying to solve a problem I had when dealing with spreadsheets and the slicers. Slicers are these controls that let you filter the information inside a data table in a Google Sheet. The problem with the slicers is that when you have many of them and you have set different filter criteria inside them, there is no way to reset all of them at once. You have to click on any of them one by one and then cancel the filter criteria to stop filtering. So I wanted a way to reset filters in the spreadsheet all at once. Imagine you have 6, 7, 8 of them. Well, there are two ways of performing this. The first one using the spreadsheet service, and the second one using the Sheets API by means of the advanced service that wraps. Remember, advanced services are no more than thin wrappers of the real APIs that lie behind or beneath them. So the problem when I do this, you can see it here in the animation, with the spreadsheet service, is that those slicers that have a different size than the standard one won't be resetted correctly. Okay? And the second problem is that the process when using the built-in service, the easy way, is much, much slower. So in this situation, you really need to go, you can do it, you can pull this with the standard spreadsheet service, but the solution is subpar. It's slow, and in some cases, it does not work well. But if you use the advanced service, it's extremely faster, much more fast, and at the same time, you can preserve the size, the preset size of the slicers that you have in any sheet. So how can you get to know this? You have to study documentation, no more. I didn't know about this when I tried to solve this problem, because there are lots of services, lots of methods, and well, a lot of moving parts inside AppScript. So the platform is very forgiving, is very welcoming, but it does not mean that it is devoid of complexity. There are a lot of moving parts, as I said before. There are nuances and subtleties that have to be learned by doing. No other way, in my view. Well, just one important thing about this. When talking about built-in services and advanced services and even APIs, don't think that that's a choice that's exclusive. I mean, well, I am using the standard service, no more. I have to rely all my code have to use only that standard service. No, you can mix them together. For instance, here I am using the spreadsheets advanced service here to create to clone, well, to reset in the end, to reset the slices, but at the same time, I am using the built-in spreadsheet service for those things that can be attained with it easier. So you can mix both of them. In the same way, you can create a script that runs on a spreadsheet, but also interacts with calendar or with Classroom, as we saw before. So you can mix services that command different apps in Google Workspace, and at the same time, you can use either the built-in, the advanced, or even the API way of doing things. There is no set way of doing it. You don't have to rely just in one way to do this, to accomplish your goals. And the third example I have here, well, we have to talk about AI, because nowadays, if you give a lecture and there is not ChatGPT or something like that, it seems lacking, I think. So I'm gonna show you a very short script that consumes an external API. It's consuming GPT-3.5 Turbo large language model to translate survey comments that the students have left in a satisfaction survey at the end of the course to numerical values, where 1 is I am pretty dissatisfied with the course, and 5 I am very satisfied. That's something that is not covered by Google Services so far. We'll have a Palm API soon, but it's not publicly usable, so we have to rely in the competition. We have to go to third parties. So let's have a look at it. I will close this. Let's open this in edit mode. You can get a copy of all these scripts and play with them. So for instance, I'm typing here, just anyone in the public, how do you feel about the classes this year? Just in a sentence. I will copy and paste that into our sentiment analysis tool we have built with AppScript. Come on. Some volunteer? I can make it up, but I think it will be more fun. Pam, 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 pam. 5. Come on. Tell me something. Give me another one. My input. Okay. Very nice course. Thanks, Luka. But lacks real life examples. 3. I guessed it. So it's good, but not so good. Good, but not too good. I guess that it will also be, it must be a 3. Good, but not too good. Okay, thank you. 3. Mixed feelings. Great. The professors are more relaxed because we are in the 4th grade. Yeah, okay. Come on, everything is a 3. I can assure you that, well, sometimes it outputs some other thing. You may have noticed that I am mixing English here. This is Spanish. This is Catalonian. Well, this AI thing is magic. It understands all languages. Let's see. Bad feeling about this. Truly depressing experience. Let's get a 1, please. That's it. maybe. No, I understand. Okay, on 1. So it's working quite well. Yes. As you can see, we have pulled a really nice, really useful. We are using actually in my school something like this for the quality assurance part. We are getting student responses in a Google form, and then a script is checking daily what they are typing and gets a number between 1 and 5. And then if something is below, is 3 or below, is sending an email to the accordingly to the person in charge, just to say, hey, something is going on with this student. Please check what's going on there. That's totally automatic, and it's working quite well for at least a couple of months now. That's the time we have been using this. Let's have a look at the code. Maybe you're expecting a lot of lines. No, I don't think so. Well, 100 lines. And most of them are comments for you with the relevant documents, docs you have to read to be able to pull this, some params, and then this part is a trigger, an on-edit trigger. I talked about this before. I talked that scripts can be run when something happens in your Google Workspace world. In this case, this script runs the actual part that does something useful is this function, this GPT. This is calling GPT, the OpenAI GPT-3 Turbo whatever model, just to, hey, this is what a student is saying, please translate this to a quantitative value. So this part is a trigger that runs whenever someone writes here or here. That's to say, when someone writes below row 4 in column B. Okay? And how is it possible? Well, we have a button here called triggers. And we can set triggers. This is my trigger. Last run, deployment, event, on edit when whenever a cell is edited, and which function is called. We even have some error rate when I was developing this, some days ago. Look, I can choose any of the functions in my script. I can select when this is going to run from a calendar event, time-driven, or from an event on the spreadsheet. In this case, it's from the spreadsheet. Which event type? On edit. On edit, it could also run when I open the spreadsheet, when there is a change in the structure of the spreadsheet, the format, the number of rows, the number of columns, or when a form is submitted, is received from a linked Google form. That easily. And the part that actually gets the job done here, that invokes the endpoint up there in OpenAI realms, is just using a special Google Apps Script service called URL fetch. I am fetching that endpoint. I am pinging an HTTPS endpoint. Maybe you will see it better like this. Passing some information. A payload has to be stringified with the model I want to ask. The model is specified here. And the messages. This is a ChatGPT model, so it likes to receive information like in a chat, in a conversation. I have to tell him first, I have to tell him how I want the model to behave. You are a quality assurance inspector working for a K-12 school. And then the prompt, this plus this. So I'm sending this here. I can specify the temperature. If you are familiar with how these models work, you know that there is a parameter called temperature that makes the model be more or less creative. In this case, I don't want the model to be creative. Temperature 0. That's to say, I always want to get the same result from the same comment. Don't make things up. And then I get here the response. I delve into the response, and return the value to the trigger, the onEdit trigger here, that writes the result in the column next to the cell where the comment has been inputted. Okay. How are we going? 50 minutes. Any questions so far? Do you think this is complex, honestly? How do you feel about it?
Just a quick comment from my side. It probably isn't pretty fair to say, since I have a lot of experience with it, but the first time I tried using it, the simplicity is actually the thing that drew me into using it more and more. So yeah, then I thought it's pretty simple for the power it has, and it actually made me continue to use it. So yeah, pretty simple.
Thanks, Luka. Well, you have a computer science background, so it's easy. But even I think I told this before. I told this to you before. Even if you don't have a computer science background, it's pretty easy just looking at how other scripts work, try to change things and adapt them to your needs. So I would like to encourage you to try. Okay? And there are lots of resources out there in case you get stuck. Luka may be one of them in your university. Okay, so that was the 3 examples I wanted to show you. Well, this is the code. We have already talked a little bit about it. The URL fetch app, the URL fetch service is very important for advanced services, for advanced apps, so to speak, and whenever you have to interact with a third-party service, like I have demonstrated just before. Okay. Well, limitations and quotas. I told you before that one of the problems that you could find in AppScript, in the AppScript ecosystem, is that maybe it does not scale too well. So maybe it's not suitable with problems that involve moving lots of data, that involve executing scripts for very long periods of time. So there are lots of limitations, and you don't have to pay. You can pay to remove those limitations. They are hard ceilings, so to speak. For instance, a script cannot run for more than 6 minutes in a regular Google account, in a consumer account. And even though that here it says that it is also 6 minutes for workspace accounts, it's false. It runs for 30 minutes. So don't tell anyone, because maybe they don't know what Google. So we can run our scripts for 30 minutes. So keep it as a secret, so that we can do it for a longer time before someone just cuts this. Another problem, for instance, is the number of simultaneous executions. A single user cannot run more than 30 scripts at the same time. And you may think, well, 30 scripts, that's all. Well, but think about triggers. I have in my school several accounts running daily processes, scripts, and I have to use different accounts because I bumped into that limit. For instance, moving data from enrollment, students' enrollment, grades, from one place to another, cleaning things, setting up users in Google Groups. So it's not that far-fetched to think in a scenario where maybe 30 simultaneous executions could be not enough. Well, there are more. Talking about workspace services, for instance, you cannot create more than 5,000 or 10,000 calendar events per day. You cannot send more than 2,000 contacts per day. You cannot convert more than 4,000 files in Drive per day, and so on. There is a hard limit on the number of actions that you can your scripts, all your scripts, not just one script, all your scripts that run under your account can create. You have a handy page here with all those limits. So take them into consideration when planning what you are intending to do. Maybe AppScript is not the right technological stack for what you are pretending to do. But in my view, it's a very capable platform that can solve, despite what this service quotas and limitations page could suggest, could let us solve many real-world problems with little or no cost. Okay, so this was the most practical part. So let's get into what you can build with AppScript. My idea is show you some examples or tell you about the different apps you can create. And to explain further about this, I have divided the scripts you can create according to 3 criteria: binding, type, and context. First, let's talk about binding. Some scripts live inside documents. We have seen 2 of them living inside a Google Sheet, Google spreadsheet. They can also live inside docs, slides, and forums. But we can also have standalone scripts. Standalone scripts can be found in the AppScript dashboard and also inside your drive as simple files that contain a script. Does this mean that a standalone script cannot manipulate data inside a Google Sheet? No, not at all. It can. It simply is stored in a different way, in a different place. So it does not belong to a editor document like these ones. Okay, if you copy a document, the script inside gets also copied, but it's a different one. It's a copy. Okay, the same as the document is cloned, the script is also cloned. The important part, type. We have what I call common scripts with or without documents. The kind of scripts I have shown you up to now are what I call common scripts. Just scripts that perform some task, and that's it. But we can also turn that common scripts into add-ons. And there are 2 types of add-ons: editor add-ons and workspace add-ons. We'll talk about them in a few slides. But why would I want to do this? Just to make easier the distribution. Okay, for now, that's the only thing I want you to know about add-ons. You can also build chat apps, little applications that run into Google Chat Spaces. The 3rd type of scripts are custom functions for Sheets. How many of you use Google Sheets? All of you, I'm sure. Nothing better. If there is something better than a script, it's a very nice Google Sheet with lots of complex functions inside, performing all sorts of calculations. Well, you can add new functions to the built-in ones using AppScript very, very easily. And finally, we also have connectors for Looker Studio. Looker Studio is a data visualization tool, a very nice data visualization tool by Google that can pull data from different sources. We can build these plugins capable of getting information from, for instance, Google Calendar, for instance, from Moodle, from Google Classroom, or whatever third-party service. Well, and finally, and this is this distinction is not really that good, but I wanted to talk about these 3 elements. Scripts can be used as they are intended. If that's a chat app, you use it inside a chat channel. If it's an add-on, you use it inside a document, for instance. But you can also create libraries, pieces of code that you can reuse in all your scripts if you want. These are not JavaScript modules. These are somewhat simpler, not as powerful, but they can be useful for people who develop lots of scripts with common parts. And also API executables. That's a very trendy way of saying that you can call a script from another script. I won't say anything more about that because I feel it's a rather advanced scenario. And finally, if you know AppSheet, the no-code platform that Google has introduced in I think it has a couple of years. Well, AppSheet was a tool built by another company. Google bought the company, and then is selling this, marketing this as their no-code solution. So you can also call helper AppScript functions from AppSheet. Well, it's really nice to go beyond what AppSheet can really do. Any of you know AppSheet? Have used? Okay, Luka, you know everything. That's great. Well, so this is the whole view. This is all more or less. I think that I have covered pretty everything. All that you can build. Let's talk about some of the particularities of any of these kinds of apps. So the first distinction I would like to mention is that between document-bound and standalone scripts. The difference is that document-bound scripts have access to a special global object called UI. You get that object invoking the spreadsheet, document, slides, or forms app, and then getting the UI. By using this, you can create menus, alerts, prompts, dialogues, and sidebars inside your documents, right? And if you are, apart from this, if you are using sheets, you can also create toasts. That's something limited to Google Sheets, to spreadsheets. Let's have a look. For instance, this is the familiar slide editor. These are dialogues that are created from using AppScript. This is a menu, okay? Dialogue, another custom dialogue, a sidebar here, populated by AppScript, and a custom menu. This is an alert, just to display information with some buttons, and a prompt used to get information from the user. And this is a toast. This is only this little window here. We'll see another one of these before I stop talking in some minutes, hopefully. This is only available for Google Sheets. All right? So that's the difference. Document-bound scripts can create all these UI elements, while standalone scripts, although they can interact with documents, spreadsheets, slides, forms, and whatever, cannot create any of these elements. So they run, so to speak, in the background. Agreed? Common script. And I'm going to go a little bit faster now. I think this part is not as complex, and I think that we are running a little bit out of time. Luka, how is it going?
It's not a problem. Just
okay.
Take your time. We can adapt.
Great, thank you. So common scripts with or without documents are or is the most straightforward way of building AppScript things, creations. So you have just to create a document, start typing inside the editor, it's here, right here, and then share your doc, sheet, form, or slide with whoever you fancy. And that's it. That person makes a copy or uses your creation, and all is fine. This is nice for private or small scale use, just for that. And it's very popular amongst what I mentioned before, that term citizen developer, non-professional developers, right? For instance, this is a creation of mine that we use actually at my school, used to create calendar events from recurring calendar events from class schedules like this. It extracts all events in a table. It detects if some classes are repeating at the same hours in different days, groups them, and creates events. So that's, for instance, a template, a shared template that is public, that is shared. It's built around this concept of just building something inside an editor. Okay, custom functions for Google Sheets. They expand the Google Sheets language formula. The Google Sheets formula language, sorry. there is a problem with them. They can only run for 30 seconds, not 6 minutes, not 30 minutes, just 30 seconds. And they have some technical caveats. They run with no authorization, and because of that, they cannot use the whole set of Google services, just a small subset of them. I think that they are declining to some point, because I think that it was in October, the Google Sheets team introducing Sheets Lambda functions and name functions. So in a way, you can build things similar to this without recurring to apps script. I have a lot of custom functions developed and published. I can, for instance, this is the last one I published. It is used, sorry, but most of my posts are in Spanish, so if you feel inclined to read, you will have to hit the translate button. I think that it does a pretty good job translating them anyway. So, for instance, here I am implementing the Levenstein distance in AppScript using a custom function to measure the difference between sequence of text. This is quite useful to correct mistakes, typing errors, or just predict a word when the user has not finished typing. So this can be attained very, very easily also with AppScript using these custom functions. Another example, we before demonstrated a way of interacting with the GPT-3 API. Now you have this in some other form, a custom function that can be used in your regular formulas. You don't need to use a menu command. You don't need to type anything, just a formula that can send any prompt to GPT-3 and get a response. Some other way of deploying the same concept, but with custom functions. Okay? And then we have add-ons. What we achieve with add-ons is just packing editor-bound scripts for an easier distribution. Not just editor-bound scripts. Because in fact, we have two types of scripts, editor and workspace. We'll talk about this in just a few seconds. There is an official Google Workspace marketplace, and you can use it to install easily, as from the user standpoint, any creation that is in the market in your add-ons. You don't need to copy a template. You don't need to copy and paste a script into your own document. You just install. I'm sure that you are pretty familiar. If you're using Google Drive, you have already installed some add-ons into your documents for to perform some workflows. For instance, Autocrat, maybe in a school context, it is quite common. The nice thing, now I'm putting the programmer cap, the developer cap. From the developer standpoint, you can publish your creations to the whole world or just inside your domain. The important thing to consider here is that if you are publishing your add-on to the whole world, for the whole world, your add-on will have to be reviewed by Google, and it can be quite painful sometimes, because they can get very special about how are you using logos, images, colors, and even how are you telling the user that your script, your add-on, is using its personal data, its personal information. But if you are publishing just for you, you can do it with no problem, with no review from Google. There are two types of add-ons: editor add-ons, they appear here under extensions, and also workspace add-ons. The difference, well, there are lots of difference besides where they appear. Editor here, workspace appear in the right small narrow sidebar that it's common to Drive, to Calendar, to Gmail. The difference is that editor add-ons are built with also HTML, JavaScript, and CSS. Only work in desktop browsers, can be used to deploy custom functions. You can build a custom function inside an editor add-on, and well, they are quite old, but the technology is proven and quite powerful. you can use it to expand the capabilities of docs, sheets, slides, and forms. While workspace add-ons are more modern and also can be used to add features to Gmail, Calendar, and Google Drive, but no forms for the time being. Also docs, sheets, and slides. They are not built using HTML, the user interface part, but using the card service. That's something new that Google came up with. And the problem with card service is that it has some shortcomings. Sorry. 30 seconds actions, similar to custom functions. The UI elements you can use in your add-on is quite limited. And in the end, we are recording, so I won't say what I really think about workspace add-ons right now. But I would say that I am not too keen on them so far. Maybe I need to know them more to love them. But so far, I'm sticking with Editor add-ons, to my bad, because Google is prioritizing workspace add-ons as a common platform. They have good points as well. For instance, they can run on mobile clients. Only for this, you know that Google is mobile first, the web is mobile first. Only for this, maybe just give them a chance as well. Don't do the same as me. So both are interesting, and depending on the use case, maybe one editor add-ons could be more aching to solve your problems, and in other situations, maybe workspace add-ons would be a much better choice. Okay, web apps. Web apps are a very, very interesting beast. I love web apps. Probably they are the most complex thing you can build, or the thing that can get more complex. What are web apps? How to explain it without going into excessive detail? So web apps serve HTTPS requests and return, as you can see here, dynamic HTML content. So they are web pages. This is a screenshot taken from a web app we have used in the Google Educator Group Spain. We perform regular, along the year, 3-4 teacher meetups where there are workshops for professional development, and teachers have to enroll, have to register, and have to choose some of them. So we developed this web app instead of using Google Forms, Google Sheets, for a lot of reasons, that streamlines this process. So in the end, what the user sees when interacts with a web app is a web page. So and this is extraordinary because web apps are serverless web applications that we can build for free with no server, with no hosting, using apps script. They run client-side inside the browser, but can get in touch with the other side, with the backend in the apps script world, to interact with Google services and get data from Calendar, from Sheets, or from whatever services you have designed the web app to use. Limitations, only 30, does this sound, ring your bell? 30 scripts, executions, 30 simultaneous executions. But in real-world scenarios, the reality is that we have used this kind of web apps for hundreds of attendants with no problem whatsoever, with the web app is not working or something like that. And well, you have some posts, you have one post here, another one later about how to build them. They are in Spanish, so I think that maybe they will be not of much use to you, unless you use the translate button again. And that's my take. Very often, web apps are used together with a spreadsheet. We all know that spreadsheets are not databases, but many times spreadsheets are used to store data, and then our web app is leveraged, is published to publish that information that is inside the spreadsheet. For instance, these are some screenshots from the web app for workshop register that I showed in the former slide. You have a sheet inside this spreadsheet with a lot of settings that make this web app behave in some different ways. messages, images, when it's enabled or disabled. We can even program when the web app is available, start time, start date, end date, lots of bells and whistles here. We also have a list of registrations that are pushed from the client part of the web app. And these are the list of workshops, the number of places that are available initially, and those that are being booked as users choose them. This is the kind of workflow that a web app can easily solve. And this is how it looks. So this web app gets settings and workshop data from the spreadsheet, from different sheets, different tables, lets the user input an input code, ID, personal ID information, email, choose with a look and feel that's much better than a Google form, which workshops the teacher wants to register in, and then updates the sheet, registrations, and workshop data according to the user data and the choice of workshops, right? This is another example. This is the schema, the diagram, the flow diagram of a web app used to publish grades of students. So these are students like you. Well, these were younger actually, and this is a spreadsheet where a teacher has collected the grades of those students. Of course, this spreadsheet is not shared with these students. Instead, they access a web app, a similar web app with a different interface, where the student has to input a personal ID and an email, maybe a password. This is client side. This is running inside the browser, but is spawned from the script running in the Google Apps script realm you have developed. And if the ID, the email, the password are right, this client side call server side, which in turn accesses the spreadsheet service, pulls the information from the spreadsheet and shows it client side in the browser. The key point here is understanding that this spreadsheet is not publicly shared, not even shared with a link, but that link is not shared publicly. It's not shared at all. Even if any user had the URL, the link to the Google spreadsheet, it could not access it. So this is the right way of perform this kind of workflow. Web apps can help us do this. I would not say now quite easily, but well, rather easily. Okay. Well, that was the hardest part. We are moving downhill from this point. Chat apps, maybe you are using chat, Google Chat regularly. If you are using Workspace, you are Workspace users, or just with regular accounts. Chat apps can pull information again from Google services, interact with users using menus. By the way, these menus are not HTML based, are created, are built using the same card service used for Google Workspace add-ons. The bad thing about the chat API is the chat advanced service is that it is only available for Workspace accounts. You can try to build something, but you can't really deploy it unless you are using a business or educational account, a Google Workspace account. And finally, we have Looker Studio data connectors. For instance, in this screenshot, you can see a connector I'm using, I built for my school, that pulls information from Google Calendar. We are using Google Calendar to represent the class usage, the room usage of all the courses we teach. And we wanted to know which rooms are more used along the year. How can we do it? We could do it with Google Spreadsheet, pull with apps, script some information into a sheet, and then draw some charts inside sheets. But we thought that it would be a much better idea to leverage the more powerful charts available in Looker Studio, and then build a connector that interacts with Google Calendar, retrieves that information, and sends it up to the visualization layer in Looker Studio. This is totally interactive with slices and is updated absolutely real time. Okay, so this about what you can build. Final slide. Well, I have some more, but this is maybe the last most important one, I would say. How can you publish all your creations? I have advanced some information regarding this, but I think that a summarizing slide is quite evident right now. So first possibility, just sharing the script, either if it is document bound or standalone. Just share the element in Google Drive, share with whomever you want. Second possibility, we have not talked about library sharing, about libraries beyond just mentioning them. Well, you have to share the script and also share the script ID. That's some information that you can find inside the ID, the apps script ID, inside the editor. So that's not very important, very relevant at this point. And the third possibility is just publishing this in some of the marketplace available. In case of an add-on, you use the Google Workspace Marketplace. Remember that you can do a public publishing and not so public, just limited to your domain publishing. You can also publish an apps script as a chat app only in Workspace, either in a special area inside a chat space where you can browse all available chat apps. And since some months ago, for the, I think it was since the last days of April, beginning of May, I think that now you can also publish chat apps in the Google Workspace Marketplace, just the same as add-ons. And finally, you can publish data connectors using a connector gallery. That's different from the marketplace and the, so to speak, marketplace of chat apps. Remember that when you are publishing something for the whole world, your app, be it an add-on, a chat app, or a data connector, needs to undergo a verification and review process by Google that can take several weeks. Okay, just some screenshots. This is the Google Workspace Marketplace. This is the general view, and this is a specific listing. This is as you can see, this is quite similar to the App Store for Android or iOS devices. This is how you can add, or how you could add, you have to add chat apps inside a channel, now a chat space. Now you can also use the regular Google Workspace Marketplace for that. And finally, this is much, well, not as visually impressive, I would say. This is how the connector gallery of Looker Studio looks. Now, remember, this was called Data Studio. Now it's called Looker Studio, but it is exactly the same beast, fortunately. And last but not least, this is how you should share a library. First, you have to get the script ID. This is the AppScript Integrated Development Environment, the IDE. The script ID is here. Just you have to copy it, publish it, and also share the script where this code lives inside. Any user can add your code just using the ID you have previously shared and reuse the library of functions that you have published. This is, well, I think more of a niche solution. Maybe your first scripts probably won't be an AppScript library, I guess. And that's it. We have some more things to, one more thing to show you, just one more thing. But I would like to make a pause here because I have been talking for quite a while and just hear you if there is some question. I see. You are speechless.
I just wanted to say that I'm pretty jealous of your dark mode because it's not available for regular Gmails, but I hope it's coming soon. So
No. My regular mode is available for you. This is a trick. This is an add-on. Yeah, you can install it yourself.
Okay.
It's called where is it? Black Apps Script, and
Okay.
it does many other things apart from a dark mode that I let you discover. Extension. I will share it in the chat. Extension. Sorry. The exact name for this was Black Apps Script. That reader, Black Apps Script. I have two of them, but Black Apps Script is better.
Thanks.
There you go. And if you fancy trying another one, not as good, not so good, I would say. I have it disabled. Let me fetch. It was. I have lots of them. I collect extensions. Wow, I can't find it. Dark reader.
It's okay. I will try this one. Certainly, like the light mode is the first thing that like.
Yeah. And this is the second one. So enjoy.
Oh, thanks. I think we have one question in the chat. I can read it if you want. It says it's by Selena. It says, how many app script functionality do you use per week? Does it save you time?
Wow, Selena, lots of them. I have a Notion system just to keep track of all of them. I use them personally and also, of course, at my school. I would say a couple of dozens of them. And of course, they are saving me a lot of time. I don't know. Do you know that meme about a coder that spends 10 hours automating something that just takes 5 minutes? Something like this. Meme automate hours. Let's see if Google. That's it. Google is very intelligent. But sometimes I feel like this guy as well, because I enjoy quite a lot coding. I enjoy discovering things. I enjoy learning. Everyday learning things about JavaScript and other technologies. So for me, spending 10 hours coding something that just saves me 10 minutes, well, it's not that bad. But jokes aside, yes, it saves a lot of times. And when you realize that this reduction, this saving comes at no monetary cost, that's great as well. And I would like to abund on this idea. You don't need to be a professional coder to take advantage of JavaScript. That's not really necessary. I know a lot of devs, especially in schools, that don't have a formal background, formal training in computer science, that are doing very great, very cool things with JavaScript. It takes some effort. I won't lie you, but it's not that bad.
Okay, great. So if there are any more questions, yes, feel free to ask. But if not, then we can maybe. Is there anything else you wanted to talk?
Yeah, three slides. See, very
sorry.
Quick slides, and Luka, I leave you all the audience to you. So we have not talked about. We have mentioned triggers. We have mentioned local development just once, I recall, at the start of this presentation. But we have not talked about deployments. We have not talked about the relation between JavaScript and the Google Cloud Platform. There is a very important, very tight relation, especially when you code add-ons. We have not delved into add-on publishing and not talk about service accounts. So I just show you to demonstrate that there are many more things in JavaScript that meets the eye at first. But this is like an onion. It has a lot of layers of skin that you can start peeling until you get to the core. Okay, so we don't have more time, but these are topics that you should remember, like important things if you explore further app scripting. 4 links there are in the slide, not commenting, for just to get started with 5 code labs, reference doc. For me, the best tutorial online, public tutorial about JavaScript, very important to master AppScript. And then a collection of resources by Kanshi Tanaikes, a Google developer expert that's an absolute legend in the AppScripting world that I advise you to follow closely. And finally, a joke. Well, I pretended to show here 9 AppScript champions that you should follow, but as you can see, I have not had enough time, and this slide is empty. So what can we do here? Well, fortunately, there's an Easter egg here in the shaking hand, moving hand. And the Easter egg is this little script, my last trick today. As you can see, I have collected in this spreadsheet. I love spreadsheets. I have said it, I think, a couple of times during this presentation, where I have some rows with pics, with URLs, some tagline, the name of the resource of the person, the champion, and well, some settings in the spreadsheet. There is an AppScript underneath. And I'm sure that you already know what's going to happen in the next 30 seconds. This script, fewer than 100 lines, is going to parse all this information and build for me a shining, sparklingly new slide here, putting all these guys, all this information in a perfectly mathematical way, a reassuring way, in an automatically, of course. So I just have pointed the presentation, the slide where I want this script to work. This is the slide. And let's see what's going on, what happens. Let's click update. By the way, this is a toast here in action. 10 seconds. I give it 10 seconds, no more than that. 11 seconds. And this was not. What has happened? This is not working. Well, the problem is that I'm watching the published presentation. Let's go to the editor, and then let's move to the last slide here, and we should have here some surprise. So I just need to reload. And again, go into presenter view to get my slide. So as you can see, AppScript is very nice at doing automations, but there are things that you cannot do. You cannot update a presentation that is in presentation mode. But I will repeat it just for you to see, just in case you think I am playing untruthful. Let's do it again. So nothing here. Let's see if it runs faster now. Come on. Wow, 11. It's late today. And here we have all our elements. This is, when I built this script, Luka, you may remember this little demonstration from the GDO talk in December. I built this just for that demonstration, and it took me about 20 minutes, 25 minutes, and most of the part was figuring out the maths here to arrange all shapes, the calculations to fit according to some columns and rows, everything on screen perfectly. And I thought, well, this is the kind of automation that took me 30 minutes and I could have solved in 5 minutes just moving things around. But I have used, this is the fourth or fifth time I have used it. So I think that in the end, it has paid all the time I spent building them in all the presentations I have performed. I have performed since that moment. And that's it. That's all I wanted. We can call it a wrap. That's all. Thank you very much for standing this time, because it's been, oh my God, 1 hour and a half, more or less. And I will be more than happy to answer any of your questions. And I have to ask you a favor, because I have my cat near my door asking to go out, so I will move out of camera for 5 seconds or so. Get out. Okay. He was trying to escape from the past 10 slides or so.
Thank you so much, Pablo. Thank you for your time. I must admit I haven't listened to such a excellent lecture in a long time. I think we all learned a lot today from you and from this excellent presentation and your examples. And I think it will mean a lot to everybody and most people and on YouTube when we post this excellent lecture.
Thank you very much.
So now we can go to Luka's part and listen what he has today for us.
Okay, so hi everyone. As you could figure out earlier, I'm Luka. I'm a lead at the GDSC at the University of Zagreb in Croatia, and I happen to have some experience with AppScript. I've just was wandering around the internet and found it and started using it. And today I would like to show you like my initial path in getting to know the AppScript, so you also have some like the best starting position. So maybe you also start using it. So since it's already 8:30. I will ask you if you want to continue after each example. I have several of them, and also if you want, we can make like our own AppScript. If anyone has like an idea what to make, feel free to write in the chat. So the things that we will mostly do are those basic scripts that are bound to docs or sheets or slides. So the first example I have prepared is something that I used when we had to write a project summary at the university. I was in a group with 5 other students, and we wanted to participate together in making the summary. But we also had like the limitations and the guiding numbers of character and the word count for each part of the summary. But as you probably know, in both like Microsoft Word or Google Docs, there is no separate word and character count for the specific type of text. You need to highlight the text and then get the number printed on screen. And if you want to know for example, every time you write a new word, what's the updated word count of the specific paragraph, then you would be clicking a lot. So I thought, well, that's something that could be automated. We can add some code behind the Google Doc and make it count words in specific paragraphs and print it out in the same document. So when we are simultaneously editing, we can then see what's happening pretty much at the same time. There is some delay due to the limitations of XScript, but it's pretty good. So I will show you the document, and then we will just go through the basic steps of writing the code and getting to the details into documentation, just like the process I went through when learning to use XScript. Maybe it then gives you a better picture of what you will need to do. So you will be able to see my screen just in a minute. This one. Okay. So this is the document that we want to add our word counter. So for example, if we just start writing, okay, we don't see the word count yet. Okay, probably there is something that we can turn on here to get the word count, and I think it should be somewhere here. Yes. Okay. And then it says, okay, great, those are numbers. And there is also an option to display it while typing. And then you have here all the necessary information. But then if there is like a lot of text and you have more paragraphs, you always have to highlight the the portion of the text you want to get the count from. So okay, my idea was, is there any possibility for it to be automated? And that's how I found this pretty cool button. I tend to click in most of my new documents now, and that's FScript. So okay, we'll wait for it to figure it out. Maybe just start with the or not, but it should be okay here. Great. So yeah, there happens to be an issue with this document. We can then maybe try opening a new one. Okay. Maybe then we can make the another way around for it not to be bound to this document, just to be a standalone script, and then use this document ID to connect to it. So that's also a thing that several accounts. Yeah, maybe this one is causing the problem. Then go to this and try again. Or just start a new window. So it's pretty handy to have someone with even more experience around. So just a second until I start the new window. It still does the same.
You have a comment in chat.
Yeah, I saw that, but okay.
Luka, you might try to open a Chrome incognito window and log in from that. Maybe you're already doing that.
Yeah, I saw the comment. I'm just trying to do it now.
Well, this is live coding. These things happen.
Okay, maybe not in this profile. We can then do it here. Okay, finally. So yeah, this is what you should see when opening the extension. It makes an untitled project in your AppScript console, and it already has one function that you can rename and then use for your document. So before we start to actually code things, we need to consider what we are actually willing to do, what we need to do. We need something that would happen every time we make a change to our document, or if that's not possible, maybe something that's, for example, turning on every half a minute or a minute or similar. And that's the thing that we also heard from Pablo. Those are called triggers. So if we want to run our script that is triggered by some event in our document, or just with the on every for example minute, then we could do this here, but we need to make the function that has the usage. So for the beginning, we will just rename the function, so we can pass it to trigger. So it's going to be like word. Okay, it should be pretty simple. We just want to get all the paragraphs from our document, and write something that searches for like a specific paragraph that has something to count, and the paragraph that we want to put something in. So, for example, let's put here word count. This is the paragraph that we want to append our word count, and then the other paragraph just below it will be the paragraph where we have our text we want to count, and then we can make it several times just for every paragraph we want to. We should have a word count paragraph just below. So probably some of those things in the chat with more words would be great to use here. So I will just copy mine comment from before. So if now this isn't turned on, but we can turn it on. So the whole document has 12 words, including the word count, but the number we want to get is 10. Okay, so what are we going to do with that? We want to find a way to connect to our document. So as you could see in the in Pablo's presentation, for every Google app like Docs or Sheets and Slides, there is a specific object in AppSheets that lets you grab the current document if the script is bound to a specific document, or just to query, for example, your drive or open the document based on its ID. So, okay, the first thing that we want to get is that document. So when I started doing that, first thing I needed to do is find the documentation. So it's probably going to be like script, the first one here. So, okay, let's see what it says. It says this one is for creating document. We don't need that. We will like to query the structure. So it says here how the whole document is divided into different parts and how are they connected in between. So we want to use something that's connected to our document. So this code here is something that gets us the specific document. So, okay, we can use that and paste it here to get the document we are currently working on. And then after a few minutes of studying this, you would get to know that every document has a body which is full of paragraphs, and that's how you get to the specific paragraph. So, okay, the first thing is to get the body of that document. So it has the specific function. So we can get the body of the document, and then if we want to go through each paragraph and see if it's named word count or not, we can just get all paragraphs. So this thing should give us all the paragraphs from our document. So, okay, if we want to use them to find the specific ones, it's probably a good idea to save them in some kind of a variable. So we can use a variable to access it later. Okay, what we need to do then is to iterate through each of the paragraphs and see if we even get all the things that we have in our document. So the second thing that you would probably look for is something like a console or a logger or something that outputs you information here that you can also test. And in AppScript, it's called logger, which has a function log that just outputs something for you. And we can maybe try to see if this script is actually working to just output those paragraphs that we think we might get from our document. So then we, after we save it, we can just run it and see if it's okay. But since it's on my drive, I need to let it Great. It says the document has 3 paragraphs, but as you probably thought, it doesn't just print out the contents of those paragraphs. It says that it's an object that's like just the type of that object is paragraph, probably a class. So, okay, now we would like to get to the content of every paragraph, but it's probably nicer if we do it in some kind of a loop, as most of you are probably familiar with, like Python or C, C++. We can use the basic implementation of for loop. So in JavaScript, we would give like starting value for some variable, make a limit that corresponds to the number of these paragraphs. It should be paragraph dot length. Okay, and then just say which step we'll use. Since we want to visit every paragraph, we'll do it just by incrementing by 1. Okay, and then this output shouldn't be just the same variable, but we should get the each paragraph using this as an array. Okay, if we do just this, we will get the same output, just not as an array, but different rows. So we need to get to the content of each paragraph. So, okay, here under the paragraph, there are some kinds of equations that we can use, but there is also text, which is the actual content of the basic paragraph like this. So if we scroll down or just open the documentation for a paragraph, here we can find that there is a get text function which retrieves the contents. So we will use that. So get text, and then just to see that it's the same document, we will do a test run. So yeah, the first one is word count. The second one is this blank paragraph, which we can erase, and then the actual paragraph if we want to count the words. Okay, so if we just wanted to count words in every paragraph, then this should be pretty much close to the whole like the solution. We just need to find a way for doing it. It's to split the text with the separator of space. So it will cut this in places where it finds the space character. And then we just want to find how many of those results are there. So the split function returns an array. So we can also just print out its length, save and see how many words are there in specific paragraph. Here we can see that it's not perfect because we have space at the end of this paragraph. So it when we split it, it also gets like the empty string at the end. But okay, for this one, it doesn't matter because we want to count this one. We intentionally put the space just to make room for the number of words in the next character. So, okay. The next thing we would like to do is to actually catch those paragraphs that start with word count. So it would be using if. So, okay, we want to check whether our current paragraph has text that contains word count in it. We also can do something like if it's only word count, or if it just starts with word count or something similar, since we want to update it even when we, for example, write a specific number here, then it should just start with word count. So we can check if it starts with word count. Okay, so if we know it starts with word count, then we can do the thing, but not in that paragraph, but the paragraph just after. So this this should be +1 because we want to get the next paragraph. We can notice here that if we go to the whole length, and the last index will then fall out of the range for this array, then we just need to make sure we don't put word count as our last paragraph, or make some additional logic that will eliminate the last, for example, just going to the one less paragraph, just not comparing the last one. Okay, so when we find the paragraph with word count, we want to get the count of the next one. Great, we can see if that's okay. So great, we just now get 10 because this one has 10. Even if we like to multiple, we would get just the ones that are named with word count. We can check if it would be okay, for example, to add then word count here, and then a few others. Okay, so now we expect 2 outputs, and we also get 1 for the first word count and 1 for the second. Okay, great. For now, it's just outputting here in our like the TypeScript console. We want to write that back into our document. So, okay, now we don't want just to read from our document. We also want to write. So the second thing would be to search whether there is an option to write something into a specific paragraph. And then we can, for example, find replace text or insert something, or yeah. So replace text would be useful, but it uses regular expressions. Maybe then we can find something more straightforward, like set text. That sounds pretty easy. So for those paragraphs, we want to set text. So the paragraph with index I is the one that we want to set text. Now, if we just give it the number, then it will erase the word count. So we also want to write that. So word count at beginning, then we just want to concatenate it with the number that we get, which is this one. Okay, and we don't need this anymore. So this plus represents like gluing together different strings. Since this is JavaScript, it's pretty good for figuring out complex operators with different types. It's not like, I don't know, C or Python that it would complain. So we can check whether this is okay. We can run that. There is no output now, but here we have 10 and 2 here. We can check if it's okay just by doing something again, and then it automatically changed to 9. Great. Now we have pretty short and working code, but it still isn't something that we want to run by hand. That's like the whole motivation. We didn't want to highlight the code. We want to make it somewhat automatic. So that's the thing that we want to connect the trigger to. So we can then go to triggers, add another one. It's automatically selected the only function it has, and we want to make it time-driven, for example, every minute. That's the earliest we can. Failure notifications are just how do you want to get the notifications if something goes bad, then it just comes to your email. So we can save this. Okay, it says it's done. Great, and then we can make some changes and hope it would also work every minute. And as you can see, it's automatically updated. It checks it for every minute. It's not very precise. You can see, I think, for every trigger when it actually triggered and how long did it take to process the function. But yeah, this is the general idea of the process of how to connect an app script to a specific document. So since it also took a bit more than planned, that's probably the only thing that we can do today. If you have any questions for me or Pablo or anyone in general, feel free to ask. And yeah, if you want, we can continue, but it's like we are here for 2 hours, so I think it's better to wrap up.
Okay, thank you, Luka, for your presentation. It was very useful. I just want to say one more thank you, Pablo, for joining us today. The presentation will be on each of our club's platforms, and this YouTube video will be posted soon, so everyone who didn't attend today's event can listen and learn something new and very special from this lecture. Thank you so much, everyone, once again.
Thank you from my side also. It was great.
Thank you for inviting me again, and well, I have enjoyed this afternoon, evening, or whatever at this time a lot being with you. And I think that it's great what you're doing at the Google Developer Students Clubs, trying to promote the use of all these technologies. So congratulations and kudos for that.
Thank you. Bye.
Thanks.
It's a pleasure
Bye.
to meet you. Bye.
Bye.